What's up, guys? This is Waleed. Today's problem is the electron energy from the relativity. So, electron accelerates space to a point where total energy is 9.5 times the rest mass energy. So they want what's the speed of the electron. So what we're gonna do is, since the total energy is 9.5, it's mass energy, rest mass energy. So E is gonna be equal to 9.5 E rest. So E total is going to be, just write it, it's going to be M C squared equal 9.5, and then the rest energy is going to be the rest mass C squared. They would change this to alpha rest mass equal 9.5 C squared. So now these are going to drop this, so we're going to be left with alpha is equal 9.5. Okay, so then from that we can go to figure out the velocity. So alpha is going to be equal to 1 divided by 1 minus v squared divided by c squared. So then we solve for v. V is equal to square root of 1 minus 1 divided by alpha squared. And from that I got 29833.000 meter per second. So that's the velocity that I got. Cool. So now what's the electron total energy at this velocity? Okay, so I'm gonna go right here. So E squared is going to be equal to PC both squared plus MC squared total squared. Okay, so from that we can go to P is also equal to alpha, so we can do P is equal to alpha mv. So from there we can go to mvc, all of these guys are squared, plus c squared total square. Then we can do squared c squared. It's just algebra. C to the 4. Okay. And then take the c out, so I'm squared c squared squared v squared plus c squared. Okay. So from there we do 9.1 times 10 to the negative 31. This is the mass squared. Then 3 times 10 to the 8 squared times 9.5 squared, and then the velocity that you got 298332110. This guy squared plus 3 times 10 to the 8 squared, and then you close out. So for this guy I got 7.788 times 10 to the negative 13, and this is in joules. And the question, if you go back to it, is asking in milli electron volt. So what we do is we divide the answer we got by 1.6 times 10 to the negative 19. Okay, and for this one I got 4868040, which means this is an electron volt, 4.868 milli electron volt. Cool. Now let's check that out. Yep, it is like that. Let's go to the third question. Third question is, what is the electron relativistic kinetic energy at this velocity? So for this guy, kinetic energy is equal to E minus E naught, and then E is equal to m c squared minus m naught c squared, and this is alpha m naught c squared minus, and then we can take the m naught c squared outside, and then so we end up with alpha minus 1, and you close this guy. Okay, so we got 9.11 times 10 to the negative 31, and then speed of light 10 to the 8 squared, 9.5 minus 1. And for this guy I got 6.891 times 10 to the negative 31 joules. We change this to electron volt. We just divide this by 1.6 times 10 to negative 19. And I got 4.307 milli electron volt. Okay, let's check that out. 4.37, correct answer. All right, so for number 4, saying if Newton's mechanics hold at this velocity, what's the kinetic energy at this point? So we know the kinetic energy in the mechanics is half mv squared. Okay, so from that we go 0.5 times 9.11 times 10 to the negative 31 times 298.33200 squared. Okay, for this guy I got, what did I get? Got 0.2533 milli electron volt. Cool. Alright guys, if you have any question, let me know. Hope it helps. Goodbye.